This is my project. My project is a cross between something called a Galton box, also known as a bean machine, or a Quincunx, and a pachinko machine. The Galton box was invented in about 1880 by this man, Francis Galton. He lived from 1822 to 1911, and his name pops up in many fields of studies. I know of him from statistics at least. These are some pictures he drew for designs of his bean machine. Over on the left is the one that's most appropriate. Balls or beans are dropped from the top. They're routed between these two guides into this array that consists of pins. The beans or balls bounce around through here, deflecting off the pins until they reach the bottom and are collected in these bins. The object of this machine was to show that the normal curve arose naturally. So if you dropped enough balls or beans through this machine, the shape you would get at the bottom in these bins would be a normal curve. If you look closely at this arrangement of pins, like looking at this little piece right here, you'll see this shape of one pin surrounded by four. This is referred to as a quincunx, this shape or pattern, and that's where that name for the machine comes from. I also was inspired by these kind of machines. These are called pachinko machines. This is an old one. You find these at least in Japan. They're a gambling machine. They have a bunch of little pins in them, which you can see here, and you drop steel balls through this array of pins, and then depending on where they end up, you win or lose money. This is an older one. Here's a newer one. This one has a video screen, but you can still see the pins here and up along the side here. These are the steel balls down here. This thing flashes and makes noise and lights go off, and that was sort of what I was trying to do. Here's my version. I wrote everything involved from scratch except for two pieces. I used the collision detector tab. I'm going to turn the song volume down for a second. I used the collision detector tab as is from Angry Droids. I'm still working on making that from scratch. And I used a modification to a music visualizer that I edited that came from a book that's listed on the submission sheet. I started from scratch with the physics engine. I imported BoxWrap 2D directly into the sketch. I didn't use their template. I also used the Minim audio library and another library called G4P GUI library. And that library has a handy tool for creating controls. You can find both the G4P library and the tool in our processing distribution if you look at the Add Library and Add Tool features that are in it. So I created this control panel over here to kind of allow me to adjust things for the finished product. But once I had created it and used it, I kind of became enamored of it, so I left it in. So let me just give you a quick rundown of what you're looking at. This center section right here is the array of pins. They're built from physics bodies with zero density, so they don't move, and then they just have a disc drawn over them. Down here we have the bins to collect the balls. These are also physics bodies with zero density. And then the bubbles you see going up and getting bigger and smaller, that's the music visualizer. If I want to release a ball, I just put the mouse in the main window and press the mouse button. You hear the sound from hitting the pin and the lights go off. And that took quite a while to get that all to be triggered correctly so that it went on at the right time and went off at the right time. If I want, I can change the color of the lights. If I go over here to the control panel on the right where it says pin lights, let's say I want to change them to green, I'll choose green, come back, now we have green lights. Maybe I want blue lights, go back over here again, select blue, and the lights change to blue. I can control the sound, the volume of the pins. I'm going to change them back to green with this pin volume control on the right, so they get louder or not so loud, depending on exactly how much you want to hear them. I can select the song I want to listen to. So, for instance, this is an old song by the Romantics. I'm going to turn the sound up a little. If I want to start over again, just put the mouse in the main window and hit the space bar and all the balls disappear. Just so you can see that again. I can adjust the color of the background with these controls. So for instance, I could make it redder, I could make it less blue. I can adjust the transparency. As I get closer to being transparent, things have longer trails. You can see the trails on the little bubble things and even on the ball. And as I go the other direction towards more opaque, they have shorter trails. And until I get up around 200, then they have pretty much no trails. The size of the bubbles are controlled by the audio visualizer. It does a fast Fourier transform on the audio spectrum and then adjusts the size of various bubbles based on those results. So it looks different for different songs, as it turns. Some are better than others. Here, let's switch to another song here. Change the color. I posted a link to this video on the submission sheet. I also posted links to 2 applications, one for Windows and one's for iOS. I can't test the iOS one because I don't have any Apple device to run it on, but the Windows one works, and it works basically the same as this. It takes a little bit longer to start up. I'm also going to have a link to a very simple JavaScript version. Unfortunately, I made this entire thing before I ever attempted to make it work for JavaScript, which was a tactical mistake. I don't think I can get the GUI stuff to work with JavaScript, at least not the way I did it here. So probably it'll be just a pretty straightforward physics example. It'll be the pins and the ball dropping through it and the lights changing and some stuff like that, but you won't have as much control over everything. Anyway, I think that pretty much covers it. I hope you got a good idea of how it works. Thanks.